to everybody for coming today. Apologies that we had to delay it for a day. I had an emergency come up. At any rate, today I'm going to be talking to you about your indexes inside a SQL Server and how to become more familiar with them and hopefully getting it further into the internals with those indexes. Click, there you go. Okay. I am Jason Brimhall, as you guys might have already know, based off of the abstract and whatnot. This is just a little bit more about me. I am a Microsoft Certified Master. Even though that's been deprecated, the title or the certification has not been removed, so anybody that gained it gets to stay it. I am an MVP for the data platform. I've got a few books out there, and this slide is a little bit old because I still call it Past SQL Saturday. It is now Data Saturdays, but basically the gist. And then front and center, most important, is the family aspect. When I'm not doing SQL, I am with my family, and we're very, very busy, as one might imagine. I've got 5 children. 4 of them still at home, and all of them very busy with different activities. So enough about me. Let's take a look at some ice breaking here. And that wasn't supposed to be ice. My slide disappeared. Great. What are the goals for this session? We want to understand what is an index. We want to be able to go and understand the value of a good index, because not all indexes are the same. Some indexes out there are bad, and they actually cause bad performance. And even if it may be good for one situation, it's overall health of the system, it just may not be appropriate to have that index there. And then we also want to become familiar with the DMOs. And DMOs, I'm sure people have heard DMV or DMF. Those are all lumped together into what's called the DMO, and those are dynamic management objects. DMV would be dynamic management views, and DMF, dynamic management functions. All right, so first thing we want to do, a little fact or fiction about indexes. So I welcome you guys to go ahead and answer a little class participation as we try to get through these different questions here. This is stuff that I pulled from Microsoft documentation. So you tell me whether this is true or false. A table can have an unlimited number of indexes. We have anybody there willing to speak up?
People are saying that it's false.
Absolutely false. All right, there is a limit to how many indexes can be on a table. You have roughly 999 non-clustered indexes, 1 clustered index, and then if you throw in, the different types of indexes like spatial or XML and stuff like that, we can actually go just a little bit above that. But generally 999 plus 1. All right. Tables have at most a few indexes enabled. True or false?
False.
That is correct as well. All right. I have come into places where tables have had, a couple hundred indexes on them. I've also come into places where they've had no indexes on them. Well, so to speak, there's a little bit of trivia behind that one too. All right. That's just a bad statement in the Microsoft documentation that you can only have a few indexes enabled. That's just kind of silly. When an index is disabled, it is deleted from the database.
True this time.
Anybody, any other votes?
Definition of index stays in a database.
That's the tricky part. Yes, the definition stays, but the data for the index is deleted. And that could be a little bit tricky in some places because they expect when the index is disabled that the entire thing is gone, the definition and the data, or the pages related to the index. Indexes are managed automatically by the DBMS.
Rather true.
This is another trick question. All right. For the most part, this is false. The part where it is true is inserts and deletes from the index are automatically performed, but the actual management and tuning of the index is not automatic by the DBMS, defragging the index and so forth, except for in some cases in Azure SQL, which is after the time when this was actually, that feature was added after this documentation was created on Microsoft. Okay, so a couple of tricks in there. For the most part, all of them were false. Two of them, they are sort of true in some aspects, but for the most part, they're false. The premise for this session started way back when I was working on a client that had terrible performance. And I'm getting feedback again. I'm hearing my echo voice. Could you, I don't know, you turned something off earlier, but I'm getting an echo. I'm hearing my voice back again. Okay. Anyway, so a client had a large database that was a warehouse management system. And I needed to track movements of all of their goods, all of their products as they moved within the warehouse and moved from the warehouse to the different stores, about 100 stores nationwide here in the United States, and thus also technically 100 additional warehouses. And every time a worker would go to pick some an article or inventory and move it to another place, they would have to sit there and wait for about 5 minutes, which was really killing warehouse productivity. And so I was brought on to try to help solve that issue. And this is basically that case study, all right? And so a lot of what we see in this session is built around trying to dive deep into that particular case to help improve performance and get further insights into indexes and how we can help. All right. Now, another side note, this was built off of Dynamics AX. If you're familiar with Dynamics AX or Dynamics Nav or Dynamics CRM, any of those products in the Microsoft Dynamics suite, you know that it's just total crap. All right. And so there's a lot of work to be done. They're not very database friendly. So, and a lot of their jargon is not actually correct in a DBMS realm. So we have to kind of, translate it. All right. So in Dynamics AX, they have these things called partitions, and they're not like SQL Server partitions, but the idea is very similar, where they can create multiple. One partition could be one store, and another partition could be another store. All right. So they could logically separate the data within the application, but it wasn't really logically separated via metadata. You had to read the data out of the database to figure out what that logical separation was. All right, so and Dynamics AX, same with Nav, they support multiple companies within the application. So that's why that's up there. It's one single company so that people could understand that this was all within just basically one database. All right. I already mentioned they're really slow. In grand total, 120 warehouse locations. It was a 2 terabyte database, so not super huge, but big enough for them that they were starting to cry themselves to sleep. All right, and they had just over 53 million different inventory types. All right, 53 million inventory types is basically on the scale of like Amazon. All right, and quite frankly, they didn't have that much inventory in their warehouse. It's just the way that they manage the system. All right. And they had no need for anything more than roughly 5 million inventory items, or not, I don't want to say items, but inventory types. All right. That's just, and that's not, when I say inventory variants or inventory types, that's not quantity of inventory. That is, okay, we have a shirt that is short sleeve. That is one inventory type. Another shirt could be long sleeve. That's another inventory type. So every time the inventory, the item changes slightly, that's a new type. All right. So however you can describe that inventory item, that is a new inventory variant. All right. So the question became, how do we make this run faster? You know, because truthfully, if it was only 53 million rows, that's not big, right? 120 warehouse locations, that's not really super concerning. 2 terabytes is not super concerning, but because of the way AX interacts with the database and 53 million inventory variants, which translated to a couple billion inventory rows, things were just kind of slow. All right, well, okay, a lot slow. And here's the kicker. All right, they were running at about 1 million transactions per second. And by the end of this, it was causing too much pain. So we had to find a way to get them past these pain points. And eventually we got up to about 1.5 million transactions per second while driving down their inventory movements from 5 minutes down to under 10 seconds. All right. So all of that in mind, what are some of the things that helped get us to making that system better? And we're going to start with the basics. All right, promised that we would look at some DMOs, and I have in red up there the AOT, and that's because that's Dynamics AX. So this is I can also present this with the AX mindset. AOT is an internal database, a couple of tables. They're not metadata. They're tables within the SQL Server database that help to maintain the definition of indexes. And it's important if you have an AX Dynamics AX implementation because those tables are total garbage. All right, the DMOs, you can see them on the left-hand side. You have DB partition stats, index physical stats, index usage stats, index operational stats, right? And the non-DMOs, these are the catalog views, internal tables, allocation units, partitions, indexes, index columns, and then sysindex keys. Now, just a little bit of chagrin over that last one because that is only there for backwards compatibility. A replacement, a SQL Server 2008 and above type of, or 2005 and above, excuse me, type of replacement has not been created yet. So you still have the SQL 2000 backwards compatible sys.sysindex keys. It has some valuable information in there that we had to use in order to get the quantity of information that I needed. All right, under the DMOs, you can see not all of those are explicitly DMVs, right? In fact, most of those are DMFs. All right, so if you take a look at index usage stats, you might want to see a open and close parentheses at the end of that, because that's a function, index operational stats as well, right? Just understand these are functions and views that are all part of the dynamic management subsystem or metadata set within SQL Server. And you can always tell the difference between those and non-DMOs because it has DM underscore in front of the name. Pretty straightforward. Just one more tidbit on the AOT. I know that we don't go into this a lot, but I had to include that there. Besides the fact that this was based off of a Dynamics AX situation, but it's also in red because besides it being crap, the SQL dictionary table there actually holds the index definitions for Dynamics AX. And Dynamics AX likes you to create the index within Dynamics AX so that in theory, the index doesn't get dropped whenever you do a code promotion for the AX code base. What I found is that's total garbage because the dictionary actually doesn't always record the index definition correctly as it was input into the application. And so you end up losing indexes from time to time anyway. And this was also part of the problem, is that in this case is indexes would randomly disappear because the dictionary had them wrong. And so more processes had to be put into place so that we could audit the indexes. And those are part of the demos at the end, where I'll show you how to audit your indexes to see what's changing with the indexes and make sure that the indexes stay in place. You would think that the indexes should always be there, but that's not always the case with Microsoft products. SQL Server, it's fine. It's the other products that are questionable. All right, so in this blurry picture page, I ask, what is an index? And everybody in the class probably already knows, and I usually ask for this, but we perform so well in the fact or fiction, we'll skip that. Oops, come on. I didn't mean to do that. All right, a little bit better picture, but it's looking a little blurry still to me. It looks better in the presentation pane. So what is an index? In SQL Server, it's basically the same thing that you see in the back of a book. You have a lookup section that records the topic and then what pages you can find that topic on. All right, and as you see in this image here, if you go about halfway down the page on the left column, AIDS medications. I can find that on pages 257, 258, 259, and 260. Inside of SQL Server, if I had AIDS as a diagnosis inside of a medical database, I could do a query and find out, okay, AIDS is actually mentioned on this page, this page, this page, and this page as the diagnoses for this patient, for subset of patients. All right, same concept. SQL Server, as we all know, is built on pages, just like a book. We just don't see those pages in the same book fashion. All right, okay. So indexes and stats. There is a strong correlation between indexes and stats. All right, and we want to go into some of the fundamentals between indexes and stats and see what that correlation is. You can see the limits for indexes. One clustered index, as we mentioned earlier, 999 non-clustered indexes per table. We clearly knew that, but what we don't get into here is all the other minutia that allows us to have more than those types of indexes. There's tricks that we can do to exceed those indexes. A friend of mine likes to say, just because you can have 999 indexes on a non-clustered indexes on a table does not mean that it is a goal. It's a limit. All right. If you were actually to put 999 indexes on a table, you could run into some serious performance issues. And I don't have any demos doing that, but I have a friend who does that demo. And just because you have that goal, because you have that limit, please don't try to come anywhere close to that limit. Generally, a handful of indexes is sufficient. Sometimes you may need, 20 or 30 indexes, but I've never seen a use case where more than 100 indexes is actually useful, let alone required. All right. Indexes can help enforce constraints. In fact, unique constraints, primary keys, both create indexes under the covers and to help enforce that uniqueness. Now, I mentioned primary keys because they create an index under the covers. So what kind of, if you tell me you have a primary key, what kind of index do you have?
Clustered.
Let's say that's another trick question. The default is clustered index, but just because it's a primary key does not mean it's a clustered index. Many times a primary key is better to have a non-clustered index. Either way, you have to have an index, all right? But the default behavior is clustered index. Many times I prefer to create a non-clustered index on a primary key and use a better index based off of the query patterns. All right. And then we have the last item there. The main purpose is to aid in data lookup. All right. I mentioned at the top, since it's on the screen, I'll talk to it a little bit. I've talked about this a few times. Two basic types. We talk about clustered and non-clustered, but we also have column story indexes. We have spatial indexes. We have XML indexes, and we have full text indexes, right? Those are all treated a little bit differently, but they can exist inside a SQL Server. I do not talk about those types at all, other than the brief mention here. There's one more index type, and we'll talk about that in a little bit, and that is the hyper compressed index that's coming up in a few slides. All right, so we'll get to that. All right. General structure of an index is that of a balanced tree or a B dash tree, not the B plus tree, and we're talking SQL Server here. Okay. Oracle and SQL Server both call them B trees, but SQL Server, we call it's a B hyphen tree or B dash tree, B minus tree. In Oracle, it's a B plus tree, and really the difference is just the shape of it and where the root and the leaf and all that actually reside. All right, the index will have a single root page, and a page is 8K chunk of data file. That's all taken from a friend of mine, Gail Shaw. All right. You guys saw all that information. Okay, here's the structure of the B tree. As you can see, you have, this is a vertical implementation of that. If you want, another way of doing this is to take that root node and just pivot that so that it's on the bottom and the leaf nodes are on the top so that it looks like a tree flowering up, and root node being 0 branch nodes, level 1 leaf nodes, 2 on up. All right. Okay. So that gives you kind of the basic structure of that. And if you look at this, the branch node has pointer records, as you can see in that blowout circle. You have a couple of pointers in there, 46, 53, 57, and so forth. Hey, what page is 57 on? You see an arrow driving from 57 to under the leaf nodes, the third box down, and you can see a couple of 57s there with additional notes there. So just like we showed in the book index image, you see the same sort of representation here. Excuse me. Okay. So we have this other type of index. It's called a BW tree. Okay. And bonus points to who can tell me where a BW tree is used. This is why I didn't want to give it away earlier.
In memory.
Correct. in-memory OLTP. All right, so the BW tree looks like this. You basically have a page mapping table. Things look a little bit different in the structure, all right, but it's still sort of similar, right? So you have root, non-leaf pages, and leaf pages, but you have memory address mappings instead of page mappings, all right? And more bonus points if you can tell me what BW stands for. While they're thinking about that, the benefits of a BW tree, it's lock and latch free index. And that part of that comes from the fact it's in memory, and you can see that it has memory address mappings. Excuse me, I gotta get a drink. BW is buzzword. Yeah, that's just mean. That's just and that's just a little bit of trivia. In internal documentation, Microsoft, they'll never release this into the wider public, but it was just an internal joke and it stuck. So BW just means buzzword. And conversely, in memory in AX, I'll just touch on this slightly because it's really, really awkward. All right. In memory structures for temp objects and in memory objects in AX has a maximum, according to them, in memory OLTP has a limitation of 128K. Now, if anybody there has worked with in memory, they know that that's just wrong. SQL Server basically will let you use up all of the memory on your box for in memory, but that's not a good idea. Basically you want to leave some cushion. The table that you're putting into in memory should be smaller than, I would leave 8 gigs. So 8 gigs smaller than the amount of memory you have available on your system. So if you have 16 gigs, your table cannot be larger than 8 gigs. All right, to put it in memory, to make sure that you still have memory left over for the operating system and SQL Server. Now, truth be told, it's a little bit more complex than that, but if you use just that simple baseline, you know that you're going to have some memory left over so that SQL Server can at least start should you have a shutdown. Because if you have a 64 gig table that you try to put into in memory, and you only have 16 gigs of memory, you reboot SQL or you bounce the SQL Server service, it's not coming back up because it can't get that memory needed for that table. All right, so you can end up with a serious server crash. All right, you want to make sure you have space left over. All right, so again, just a little more stinky cheese for AX. And then now on to stats. And here's where it usually gets somewhat confusing, but it gets a little bit clearer when we get to the demos. Every index has a corresponding statistics row. Remember, I talked about there being a strong correlation between indexes and statistics. So if you go and create your primary key and you create a clustered index, the default index with your primary key, automatically you're going to get an index ID equals 1, but you're also going to get a stats ID equals 1, right? Because it creates a histogram with a stats ID that is the same as that index ID. All right. So now when I go and create, and that's that last part of the statement there, not every statistics row has a corresponding index. So let's say I created that clustered index, then I go and create 4 stats. So those 4 stats will get stats ID 2, 3, 4, and 5. So now I have 5 rows in stats ID, but I only have 1 in the sys.statistics versus sys.indexes. Right, so in sys.indexes, I will still have 1 row and it will just have ID 1. Now let's say I go and create a non-clustered index on the same table. what will be the index ID? The index ID will be ID 6 because stats ID, because of that correlation between stats and indexes, and the two of them have to have the same ID. And since I already had stats IDs 1, 2, 3, 4, and 5, in order to create the next stats ID, it would have to be 6. So we create an index ID of 6. All right, that would be, even though that's your first non-clustered index created, and it should, in theory, be 2, it's only going to get that if your stats were not created on the table before the index was created. Or if there's no stats currently on the table, would be more accurate. All right, clear as mud? Okay. Let's go ahead and drop into demos. And the first demo that we're going to look at will be that actual stats ID. All right, it's not letting me move that. There we go. I'll just give you a little bit more room. Is that large enough for everybody to read? Do I need to zoom it up a little?
Can you make it a little bit bigger?
That look good?
Yep, thanks.
All right. So here, I've just got a demo. I'm just going to go through that, what we were just talking about, the creation of statistics and the correlation between your indexes and your stats. Now, what I did not check is to make sure that that is a heap only. I gave you guys a bonus question. Is a heap an index or not? It's a binary question. It's really easy. A heap is a type of index. It actually gets index ID 0. And I'm just, come on, this thing's running slow. And I'm just, so it gets index ID 0, but that means basically everything is an unordered mess. So you dig a hole in your backyard and you're throwing all the dirt out onto a tarp on the ground outside of the hole. You can't tell me where each grain of dirt actually came from in that hole. Whereas if it were a clustered index, it would be placed in some sort of order so that you would be able to put it back in its exact place. Not that you would ever want to do that. But all right, so this table is a heap. So tables come in 2 types. They're either a heap index or they're a clustered index. All right, so as we work through this, you're going to see that the very first things that I'm going to get, I'm just comparing in these first 2 queries. What? I just verified that it's there. See, demo fail. That's why it's not there. Okay. So right now you can see XE targets, the table that I'm looking at. It is index ID 0, has a type description of a heap. All right. But I do have 3 statistics on there, 2, 3, and 4. I only have 1 index on there, and that's a heap. All right. Why did stats ID skip 1? That's an easy answer. This is the one exception to the rule I was talking about earlier. A clustered index always has to be ID 1. There's no way around that. Clustered index has to be ID 1. So stats can't start, the custom built stats or the system built stats cannot start until ID 2. All right, so you see here we got stats ID 2, 3, and 4. They're already created on the system. And I'm going to go ahead and create another stat here. And then we'll query it right away after I create that stat. This is getting in my way. I'm just moving these back out of the way so I can get the full screen back on this. There we go. Now you can see the full text of what I'm looking at. All right, so very simple. I'm creating a statistic named SQL Ver on XE targets on the column SQL Ver. All right. So once I create that, and then I'll requery sysindexes, and I will requery sysstats, and you'll see the difference between the two. It's going to take it a lot longer than normal. Okay, so the index you can see here, still a heap, right? So no indexes there. We have this new line down here at the bottom. We now have stats ID 5, and we have that custom stat created. All right, so that's after stat was created. So you can still see we only have the one there. Let's create an index, do the same test. Holy cow, I've never seen it run this slow. It's just special for today. Okay, it should be finishing here any second. Or maybe minute. Nothing like a demo that runs slower than you're used to. This is what everybody loves to watch here, is just a spinning wheel. Well, I'm going to go ahead and go on to the next demo while that finishes. And we'll come back. What you'll see is that the index ID will change there, and we'll come back and we'll actually just finish out just the last few queries after we drop. Oh, look at that. It threatened that we're going to take off. All right, so I created a non-clustered index. All right, see how it jumped to index ID 6. All right, and that's because it needs to match your index ID down here, or your stats ID down here in this table. All right, so we'll have 6 stats, so we have to jump to index ID 6. Let's go ahead and finish the last one. And I'm not taking chances that it's going to take as long, so we'll go on to the next one. And okay, I'm going to pump this up just a little bit larger. These are just some quick queries to help you check and validate your stats, your statistics inside of your database. All right, user created stats, stats specifically on indexes, and I did not go into stats that were created by Microsoft. There's a fun little algorithm on that. Yeah, I don't want that on the master database. Oh, I guess I don't have any stats because I haven't used this instance enough. Okay, well, forget that. I really don't know what's going on. Everything is just not, it does not want to work today. Great, Management Studio crashed on that one. Oh, did it come back? Okay. That's running. So we have here, back to that last demo, while that one's just running, you can see we're back to a heap. We just have the original 3 stats back on the system. Index is gone, the custom stat is gone. We no longer have stat ID 5, we no longer have stat ID 6. Okay. And while that other demo is running, since it's I don't know why it's not pulling up. It's because I've not got enough usage on this instance that I'm showing you right now from here. But so the gist of this query is just to figure out what the user created stats are, and it's real simple to just look for that through s.userCreated equals 1, s being sys.stats. All right. I'm also checking against this DMO right here, sysdmdb stats properties. That way I can pull in from there the last updated date. And then I like to compare that with stats date because sometimes they're just not the same. All right. And then when we take it a little bit further, as I mentioned, the strong correlation from stats to indexes, I can go stats ID equals index ID, but I also want to make sure I have that joint on object IDs, and then I can get all the information there. And in this case, I had some additional things there for, I was looking for statistics, not indexes. And so you have specific things right here. Yeah, stats specifically on indexes. And I was looking for stats where I had, there were some anomalies that I saw where you have some stats are named I underscore. So I want to make sure I'm looking for indexes with my specific naming pattern. All right, so I can make those exclusions. Is this finished over here? And it came back with nothing. All right, well, we'll just chalk that one up to demo fail. We're gonna jump, actually. Part of what helped to make things run faster with that scenario where we had just terribly performing queries in the warehouse case study was to create filtered stats. or basically poor man's partitioning on the largest tables so that we could break down those inventory items appropriately. And so through the use of filtered stats, now there's a benefit and there's a cost. Nothing comes free. Through the use of filtered stats, I could create more than the 200 steps associated that are a limitation in statistics. All right, so I could go and create maybe 100 different stats on a very large table. Now I got 200 steps for each of those stats. And what that will do is it'll trick the optimizer into giving me, 40,000 different steps and give me better execution plans on what is happening. And I think I said 200 stats, and so 200 times 200. All right. So it'll trick the optimizer into giving us better execution plans because I have a whole lot of different stats and I have a better display or a better view into what my distribution of data actually looks like. So we can trick SQL Server through the use of poor man's partitioning, but that poor man's partitioning is through the use of filtered stats. And that takes 3 stored procedures here that I've worked on that'll do that. SQL Skills has very similar stored procedures that will do the same thing for you. All right. The downside is when your data keeps evolving and changing, now you got to come and rebuild these statistics. So you got to drop them and recreate them every so often. So there's an added maintenance cost, but that maintenance cost offsets because you have such a huge benefit. So just some things to take into consideration. All right. I'm going to skip that. I don't even know where. Okay, I'm going to jump over here into index deep dive, and it locked on me. So let's zoom this one up as well. Just a moment. All right. The output on this is a little bit small. I'm just going to talk through it real quick. This is a very large script that I've worked on for many years, and it just keeps getting larger. All right. This basically boils everything down for deep insights into your statistics and into your indexes. And like for instance, this last one right here, I'm getting all the stats information related to various different queries and objects. All right, so I can understand the stats there, and if I need to do something a little bit differently with those stats, if I come up just a little bit further, get rid of the results here. What I'm doing here in this very large section, let's get all the way to the top of this section. Maybe. I am testing the compression. So I'm doing a compression analysis for for every table, as long as I have the parameter set. Why do I have it set that way? Well, it's a very resource intensive operation, and it will take a long time. So inside this if block, I'm telling it if compression analysis equals 1, then we're going to go ahead and do this huge block that is from 1846, right? So roughly 1,600 lines right there to perform that block of code. All right, and if you look inside of it, you'll see that what I'm relying on to do some of that, because I did not want to rewrite all of it, was Microsoft's stored procedure, SP estimate data compression savings. and I do an analysis to see, and also to check column store compression, so page compression, row compression, and there's an output that comes with that. And I want to see all that stuff. If we get further into this section, I think it is right here, I'm analyzing heaps. I go through and do missing index analysis, which is right around in this area. All right, so a lot of different things going on in this. You can see, we'll just drop through it real quick. I give output to tell us what it's doing. It gives me table storage estimates, index analysis with stats processing. I go and look at the actual key size for the database. I look at the fan out, and we'll go and look at the fan out in just a minute. And then I process what the actual index definitions are, partition alignment. So fun fact right here, just because I heard this from somebody the other day. So he told me my table is partitioned. All right. What is your partitioning key? Partitioning key is month ID. All right. Is your partition, is your index, is your clustered index partition aligned? All right. So, and he said, well, my table is partitioned. So by definition, the indexes, all of the indexes are partition aligned. Fun fact, just because you partition a table does not mean your indexes are partition aligned. All right. So the partitioning key was month ID. His clustered index was on product ID and formulary ID, and there was one other, and then month ID was the fifth item. So ordinal position 5. So I want to process partition alignment to make sure that indexes are properly aligned with it, so that you can get that partition elimination that comes with it. All right, we look at tree and leaf and fragmentation, and so if you were to take a look at this script in the demo scripts on another important one, and I'll talk about this one specifically. I mentioned earlier, just because you have indexes on the database does not mean that they are beneficial to your environment. So we talked about exceeding 100 indexes and that not being beneficial. Too many indexes is bad, right? Well, you could also just have 2 indexes on your table and still have performance issues caused by one of those indexes, and that comes from the indexes being duplicates. And the reason that happens is because now you have to do double the maintenance for half the benefit. Does that make only one of those indexes can be used if they are full duplicates. All right, so one of those, you're just using that, you've just got this index out there that is doing nothing but costing you, and it's not providing any lookup value. And indexes are only there for lookup value. I had another case where it's very simple, but relates to duplicate indexes, where the DBA had gone in and created indexes specifically for update and insert statements. And then, so he named his indexes by the scheme index underscore table underscore insert, index underscore table underscore delete, and index underscore table underscore select, because he thought that each of those indexes would be used for different operations. That's not the case. All right. Indexes are used for lookup operations. If a lookup operation is necessary for your delete operation or your insert operation, it'll be used. But the only time it gets touched for an insert or a data modification operation, the only time it gets touched is so that the index can be modified itself, unless it's part of the lookup first. But so in overall, having an index there for a data modification, it's just going to add extra cost. All right. You don't have indexes for data modifications. They're for lookups. All right. So let's go back to the results real quick right here. I'm going to blast through these so you can see some of what we have here. Just initial output. I'm gathering all the table sizes right here because I want to see what tables are actually causing me potential pain. All right, so if I look at this and I say, okay, this has an index size, right now it's only 0.03 meg, but what if that index size were 200 gigs and the data size was only 10 megs? That to me, it would be a hot button, and I would immediately go look at that table, right? I'm also giving you output to do an aggregation of the total number of indexes on this particular database. So we can see here, based on this database size right here, this is not a very big table, but it has 7 indexes. All right. If I sorted this by the actual table size, the largest one, I would see probably different stories, right? And I'm just trying to scroll real quick to see if I have a really large one to illustrate that. And nothing's really standing out. Okay. This next section right here, I threw in output so that I could single this out. So this is binary comparisons. And why did it do that? That's lovely. Okay, well, so binary comps or binary comparisons let you know, and I've got the column right there, how useful the index really is. And fan out kind of correlates to that. So for each that lets me know how many pages are in each are fanned out from each level, right? So this one goes 18 pages wide, all right, and it only needs to look at 4 pages for every lookup. Now that's useful for me in knowing that, okay, so if I only have to go do 4 searches across pages, I'm getting pretty efficient. If it were only 1 page, I'd be a little bit worried. If it gets up to 10 pages, I'd be a little bit worried. So I'm looking for some number that is between realistically 4 and 7 on this to say, okay, that index is probably working efficiently. But I get down to, say, this one right here, where it's at a 2.3, and I might be looking at that and saying, okay, for 1,300 rows, fan out of 5, that index may not be as helpful as we want it to be. All right, so I'm using that information just to gauge, again, where I might have pain points in the database. All right, I'm going to skip down index analysis, or fragmentation analysis, excuse me. All right, we have on this one, so I have an additional column on this that is called the disable statement. And I have that there, if I can get it wide enough, to illustrate why I might want to disable that index. And usually, I don't have it here. Oh, no, it's okay. Usually it's because that index has not been touched at all. All right, and it has something else going on with it, like it has, well, I have that down here. It has been detected as a duplicate, or it's not being used at all. So I'll add in the disable statement. The index definition will still be there, but I'll eliminate the cost right there. Another issue that I see frequently is people have disabled page locking. So they only want row locking, which really slows things down. You only want to disable page locks in extreme controlled circumstances. Okay, and we will generally want to turn that back on. So I want to detect for that. All in all these demos, for what they're worth, will be on the, I'll have them available for download, and we will, you can look through that a little bit more so that you can understand that. I did not get to the index audit, and it didn't show the missing indexes. I wanted to get to that, but we are at time right now. So I apologize. It's a lot of demo content, and unfortunately some of the demos were having problems today. All right. If you want to reach out to me, you're welcome to do so. Here are all of my different contact informations. We've got my Twitter handle at SQL Runner, my company handle at DBMasters with a Z, and then the websites that I manage, SQL Best Practices, and which is SQLBP.com, jasonbrimhall.info. Willing to reach out to you. You want to connect to me on LinkedIn, you're welcome to it. I appreciate your time. I don't know if we have time for questions or if there are questions. Okay, if you have anything, go ahead and reach out to me through one of those channels. Thank you for your time.